Hello class, I'm going to go over learning prompt 5 for anyone who had trouble with this. This is all about contingency tables. So let's go to this assignment. The first thing we need to do is we need to bin our wages. So we're going to bin wages into these 3 levels. So let's do that real quickly. I'm going to go to transform. I'm going to go to bin. I'm going to check my variable to be wages. I need to look at what it was. So it was 3 levels, less than 75, 75 to 14999, and 150K or more. That means I need 3 levels. I do that by inserting a break. That gives me now 3 levels. I start at my highest value, 150,000. I didn't type it in very well. Okay, 1, 5, 0, 0, 0, 0. That's 150,000. My next one goes from 75,000 up to all the way up to 150,000, but less than 150,000. And then the last one is less than 75,000. So you can rewrite the labels or not. I've been basically saying if you're not sure you're right, don't rewrite them. If you're positive you got it right, then rewrite them because it's a lot nicer to look at English. 75K, this is 75K to 150K. It's actually just a touch less than 150K. So you should say it's 149,999 and then drop the K. K is just 1,000. And this is 150K or more. And we're just going to call this wages 75, 150. I did that kind of fast. Hopefully you can pause that if you want to see it again. Next is we want to do our filters. We're looking at privately employed 28 to 32-year-olds that work 40 hours or more. So we're going to go 28 to 32. Get there. 28, 32. We want them working 40 hours or more. 40 hours or more. We want them to be employed, and we want their work class to be private. Because the government just don't pay what the private industry pays, as all teachers know. All right, so I think we got it all. I should have 1673. 1673. So what we're going to do is, I like to do the bar chart first. To make a bar chart, we select always the response variable in this location. The response variable is our new wages, and we're going to group it by sex. And basically, I click a lot of boxes. If you just generate it as is, you have counts, which aren't the best, so you really need to have relative frequencies inside of each group. That at least makes like the color, the combination of all 3 of these colors adds up to 100%, adds up to a full 1. This is fine. You could totally use this. There's nothing wrong with this. A lot of people like this. I tend to prefer to like to see it stacked, and I like to see it flipped because I just think this is kind of easier to look at for me, for a lot of the stuff that we're doing. Might not be true for every time you make a bar chart, but for the things that we're doing mainly in this class, looking for association, I think this does really well. And then we follow this up with a table. The table is going to tell me the exact same thing. The row is going to be the same thing that is across the row here, which is male and female. And the column is, you can think about this as the columns as being filled up by the wages. So I'm going to type in wages. And if I just generate as is, I just get counts, which we don't really want counts. If I do relative frequencies, I get like these crazy decimals where all the decimals add up to 100%, which is really not what we want either. What we want to do is we want to calculate the percentages across the row. This lets me say that there are 17.9% of females making 150,000 versus 29% of females, 29% of males making 150,000 or more. So that gets me my information, has me my bar chart, it has me my table. The second question asked us to do the same thing, but instead look at educational attainment. So I'm just going to replace wages with educational attainment and generate this, and I get the educational attainment view. Now this is sometimes hard to get into So I shrink my screen. You can go here and just shrink, do a zoom out. So you can zoom this and be able to get the whole table. Or you got to do two smaller screenshots by sliding around things. So you get this. I prefer to look at it though in a bar chart. So I do bar chart. Again, I'm going to put the variable is my response variable, and the group by is my explanatory variable, and I get this graphic here. When we can look at this, if we look at it closely, we can see 30% of females have masters versus only 25% of men. So there's definitely, a difference here. We can see like there's quite a bit more men that have less than a bachelor's degree. These are the first 4 bars. The women, it's quite a bit smaller. We also see there are more females with professional degrees. When it comes to bachelors, they're pretty even. I mean, in general, we see a similar distribution, but the women have a greater distribution right here. This is almost like a 5% greater, which is kind of surprising. I mean, in my opinion, this is pretty surprising that it looks like 4.5% have master's degrees. And this is another big percent from 4 to 1. It's like 3 percentage points higher. So it looks like females, in my opinion, are slightly better educated. Not by a whole lot, but slightly better educated than men. But it's not they're not making more money than men. They're making less money than men. There's fewer making 150,000, and there's much more making less than 75K. As I think more and more about this, I think this is possibly due to the fact of different ways that men and women negotiate their salaries. Maybe men are a little more apt to negotiate a higher salary than a woman. Maybe a man, gets promotions quicker than a woman in the workplace. I'm not exactly sure what all is about the gender gap. I've never really studied it besides just looking at the data. And then the last question here, question 4, says, what if we just look at people who are all working in the computer-related professional and have a master's degree? So, because it might be that men are choosing to work in higher paying industries than females. So we're going to kind of eliminate that potential error here, and we're going to find only people that have master's degrees, and we're going to find people that are only working as computer-related professionals. Create our filter data set. It's a lot smaller sample, so that does give us some troubles now, because there's a lot of natural variability in the data, meaning that sample to sample variability is high because we don't have a large sample. We don't have a lot. Like, the larger your sample is, the more confident you can be in these results. If you look at this data, if we go to the contingency table and we do sex here as the row, and we do the column as the wages, and we display this properly, you can see that there's only 74 men and only 50 women in the sample. But we do see a pretty big difference, 40% versus 60%. We got 20 out of 50, and here we got 44 out of 74. It's probably not that likely that this sort of a difference would happen just due to chance in the sampling process. And also, you only see 2 men out of the 74 reported earnings of less than 75K, but that number jumps up to 8 out of 50, which is 16%. So I think we're seeing some pretty big differences still. But definitely, both groups are making more money than they were before. Now, I don't know if we could fix this anymore. To me, the one thing I thought we could look at would be people with the same citizenship status, because that could affect pay. If you're here on a visa, maybe that affects how it's going to work out in the workplace. I thought maybe looking at the degrees could be interesting, because if you look at this, even though these people are working in computer-related fields, their actual field of degree looks like there's quite a bit of variability. 33% have something other than the top most popular degrees. If you look at computer engineering and computer science, those are the 2 highest, and electrical engineering. So maybe if I would do one more thing, I would look at field of degree, and maybe I would look at computer engineering, computer science, and electrical engineering, figuring that these are kind of maybe the higher paying of the degrees. Now, I don't know how these relate, We could do something like a contingency table, and we could look at, are men and women equally likely to have these degrees, if these degrees are what's setting the money apart. Definitely the men are more likely to have a computer science degree than women. So electrical engineering looks the same, computer engineering, a lot more men, but the percentages aren't terribly different. So we could go back and look at this same thing. We could go back and look at this bar chart. So there are ways to maybe make the analysis a little more fair between the men and the women, because you don't want to make a conclusion that has some other like lurking variable that's kind of affecting it. Here though, we still see that 63% versus, it hasn't changed that much even though we looked at only these degrees here. So I don't know, it's a little strange. We could do one more thing. We could do contingency table. This one's going to be hard to look at though, I think, because I'm going to do wages. I know I'm going overtime. I was curious. We could look at this. This is a lot, but here's, if you look at computer scientists, males and females, there's only 5 in the sample, so these numbers are sort of hard to look at, but at least we got some picture of it. The differential is not too great, 40 versus 55. For men and women with computer engineering degrees, it's a very big difference. Again, sample size is pretty small. Electrical engineering degrees also. So if you were going to do this analysis and you even wanted to expand upon this, then maybe you could shift the age, although usually when we make the age small is because we want people at the same stage of their career, and we start to run into troubles when we do increase the age here. But if, for instance, maybe we could look at people who are kind of like mid-career, people in their 40s. I don't know if I'll get there. Say people like in their 40s, so we have like a larger group to look at, which will increase our sample size. And then we could regenerate that same contingency table and see what it looks like. It gets a little better. So here's females. You got 61% versus 90% though, so it's not really looking that much greater. But we are suffering again that there are very few women with these degrees, especially when we start to look at older women past, in their 40s. There was probably not as much access for the women. Although here, it's a smaller group, but electrical engineering, we see 5 out of 6. So it's tough. We have limited data because we're only looking at one small geographical area. But one of the things when you do look at wages is wages are very tied to geographic areas. People make more money in some locations than other locations in the U.S. Anyway, okay, just trying to give you a little bit of this is a more complicated issue when you're looking at gender gap. You have to look at people that are doing similar work. So it's challenging. Anyway, okay, that is it for today.